Greetings to everyone. Today we will be doing the convergent geometric series. A convergent geometric series. So if we can consider the following geometric series, we've got 1/2 plus 1/4 plus 1/8 plus 1/16. So the following two terms will be 1/32 and 1/64. Okay, as you can see that what to call the denominator of each term is multiplied by 2. So here we can work out the sum of the progressive terms as follows. Okay, we can just say, okay, the sum of the first term, that will be 0,5. Okay, the sum of the two terms, we've got two terms here, it's 1/2 plus 1/4. So we get what, 3/4, which gives us 0,75. And sum of the three terms, that will be 1/2 plus 1/4 plus 1/8. We end there, so it gives us 0,875. The sum of the four terms that we want to 3 for the sum, to be 1/2 plus 1/4 plus 1/8 plus 1/16. That will give us 0,93. So from here, as we continue adding the sum of the terms, we could see that there is a certain number that is being approached by this series. Okay, so this series goes to 1. Okay, it goes to 1, it gets closer to 1. So this type of a series is said to converge to 1, and the number to which the series converges to is called the sum to infinity. The sum to infinity of the series. Okay, now there is a useful formula that we use to calculate the sum to infinity. Okay, this is the formula. Now we only use this formula only if r is greater than -1, but r is less than 1. Okay, now if we still consider the previous series, that one, it is very clear that we know that a, which is being the first term is equal to 2. The first term is equal to 1/2. There we have the first term. And r, which is what? R, which is the constant ratio. How do we get that one? We say we say term number 2 divided by term number 1. That will be 1/4 divided by 1/2. What do we get? We get 1/2. Okay, this is our constant ratio. So we can always put from this formula, we can put this formula that we use to calculate the sum to infinity. You know that a is what? Is the first term, and r is the constant ratio. So we put 1/2 there, and we put 1/2 here. This 1/2 here is for a. This 1/2 there is for what? Is for r. So we can see that the sum to infinity for this series is what? Is 1. So when a series is said to converge, we know that the constant ratio must be between -1 and 1. So once the ratio is outside this restriction, now our series is going to be divergent. It's not going to converge, and we're not going to have sum to infinity. Okay, let's say maybe if r is equal to 2, so the number will continue being big. Okay, so we are not going to have a certain number that the series approaches. Okay, in this case, our series approaches the converge to 1. So the sum to infinity of the series is equal to 1. Okay, and then its geometric series will only converge if the constant ratio is between -1 and +1, like I did there. Okay, in other words, the sum to infinity for a given geometric series will exist only if r is greater than -1 but is less than 1. If the constant ratio lies outside the interval, then the series will not converge. So we say the series will diverge. Okay, now let us look at this example of this geometric series 1 plus 2 plus 4 plus 8 plus 16. It will not converge since the sum of the progressive terms of this series diverges. Why does it diverge? Because r is equal to 2, which lies outside this interval. Okay, so it will continue. If you add these values, we're gonna keep on getting a big number. So this series does not seem to approach a certain number. Okay, now let us come and do the example. Okay, now we are asked to do what? To calculate the sum of an infinite geometric series. Okay, this is the series. Okay, so now we know that the first thing that we need to get is what? Is r. Okay, we need to see if r lies in that interval. Okay, so we're gonna say, okay, this is going to be 2 over 3 divided by r, which is what? Which is t2 divided by t1, which is going to be 2 over 3 divided by 2. Now what do we get there? 2 over 3 divided by 2, we get 1 over 3. Okay, 1 over 3. Okay, 1 over 3 is greater than -1, but 0,1 over 3 is also less than 1. So we are going to get what? We are going to get a convergent. This is a convergent series, so we can get the sum to infinity. Okay, and then we determine what? We determine a. What is a? A is the first term. What is our first term? Our first term is 2. A is equal to 2. Okay, so we come to use our formula for what to call determining what? The sum to infinity. We say the sum to infinity is going to be equal to a over 1 minus r. Okay, provided that what to call r is greater than -1 but less than 1. So we're gonna see a is how much? A is equal to 2 over 1 minus what? 1 minus 1 over 3. Okay, so our series will converge to, say, 2 over 1 minus 1 over 3. So our answer here is 3. So the sum of this series will converge to what? Will converge to 3. Okay, good. Now let us also do example 2. Okay, now our question is in the form of a sigma notation. So we already discussed sigma notation on the previous lessons. So how do we deal with this one? So with our solution, so we'll first need to find what? To find the series. Okay, starting from 1. Okay, so this is how we're gonna get the series with a sum to infinity n is equal to 1, and then this is 2 times 10 1 minus n. Okay, so we're going to start by substituting 1 there. This is going to be equal to this is going to be 2 times 10, 2 times 10, and we say 1 minus, no, it's supposed to be, this 2 is supposed to be outside the bracket. It's supposed to be outside the bracket. 2 times 10, 1 minus 1, we start there, we start at 1, and this is plus, we come again and we say 2 into 10, 1 minus 2, plus 2 into 10, 1 minus 3. Okay, now let us just do the last term. That will be plus 2 into 10, 1 minus 4, plus etc. Okay, going forward. So what do we get now? This is how our series is going to look like. This is going to be 2 times 10 to the exponent 1 minus 1. We have what? We have 2 there. 2 plus 1 over 5 plus, we're here now, 3, 1 over 50 plus 1 over 500. This is how our series looks like. So we have to find what? We have to find R. We have to find R. R being equal to what? T2 over T1, which is going to be equal to 1 over 5 over 2. Okay, R is going to be equal to 1 over 5. It's going to be 1 over 10. So 1 over 10 being 0, 1, 0, 1, and being what? Being greater than -1 but less than 1. So what is our A? Now let us find A. Now let us find A. A is the first term. A is going to be equal to, A is equal to 2. A is equal to 2. Okay, so we come to our formula for sum to infinity. The sum to infinity is going to equal to A over 1 minus R, provided that R is greater than -1 but less than 1. So A is going to be 2 over 1 minus 1 over 5. Now our series is going to converge to this number. This will be 2 over 1 minus 1 over 5. So the answer is 5 over 2. The answer there is 5 over 2. So this series is going to converge to 5 over 2. So this is how you calculate the sum to infinity of a convergent geometric series. So how do we know that the series is converging? By just determining R, and if we find that R is between this restriction, then we know that we've got the sum to infinity. That is the end of our lesson. So thank you.